So in a certain area in the American Southwest, there were these volcanoes, right? And about a century ago, these volcanoes erupted. And when they erupted, they left a residue of lava that left much of the ground black, right? And in this area, there were these mice, right? And these mice, before the eruption, had white coats, overwhelmingly white coats, right? And if you can picture my black canvas as the black rock that was left over after the eruption, if you were a hawk or some other predator in the sky, these mice would be easy pickings, right? They're easily visible from the sky. They contrast very well with the ground. Thus, these mice are at a disadvantage. They are a lot easier to see and more susceptible to predators. However, there was a mutation in this population before the eruption where some of the mice, right, not a lot, only like, in this room, maybe one, maybe two, actually were black. And if you can see, and it's hard to see in this canvas, and that's the point, these mice would be a lot harder to spot in the air after the eruption when the, magma cooled, when the lava cooled, because their fur color is very similar to the black rock that was left over. Thus, predators would have a lot harder time seeing them and eating them, right? So over time, this population changed, and now, overwhelmingly, the amount of mice who have black fur outnumber vastly the amount of mice that have white fur now. And this took just a century, right? So before, black fur was, very, very rare in this population. Now it is prevalent. It is the default, if you want to think about it like that. And this is a great example of evolution, right? A change of traits in a population over time, right? Specifically, this is a great example of natural selection. And a lot of the time you hear natural selection and evolution used interchangeably, right? But they are not. Natural selection is a driving force where the most fit individuals, fit for their environment, reproduce and, make their traits more prevalent in a population, right? So a lot of the times you hear survival of the fittest, and when you hear that, you might want to think about someone that's physically fit, strong, muscular, and able to run fast. But that's not necessarily the case. It's just fit for population. For these mice, having black fur after the eruption was more fit because they were better able to survive, and mainly they were better able to reproduce. If you're able to reproduce more, your traits have a better chance of getting passed on. That is the driving force of natural selection. Right, so if you want to think about giraffes, having a longer neck is more fit in that population because you'd be able to reach higher trees and eat more food, be more healthy, produce more offspring. That is natural selection. And natural selection is just a cog of evolution. It's just one part of evolution. Another part is called genetic drift, right? And the main difference between natural selection and genetic drift is that genetic drift is completely random. Now, the mutations of a gene that produces a trait that might be more favorable in an environment, like, for example, a black fur coat instead of a white fur coat in those mice, that mutation itself is random, but its ability to become more prevalent in the population over time because it is more fit is not. That's natural selection. That's a driving force. Genetic drift is completely random, a random change in traits of a population. And to, demonstrate this idea, I'm going to go ahead and I'm going to change colors here, right? I'm going to have a population of 20 individuals, right? 10 of those individuals are going to be blue, and 10 of those individuals are going to be red, right? And you can think about, these colors representing anything: fur color, hair color, eye color, height, or whatever you want, right? Now, just by chance, not everybody in this population is going to reproduce, right? So just by chance, let's just say these 15 individuals reproduce, right? The 5 blue ones at the top do not. By chance. There's no difference in, whether you're red or you're blue and your chances of surviving and reproducing. It's all the same. Just by chance, those 15 reproduce, right? And let's say they reproduce and provide identical offspring. We're not going to deal with, alleles and probability right now. We're just going to try and keep this simple, right? And now you have a population of 15 individuals, right? And now, before, when it was 50-50, between who's red and who's blue, now there's a lot more red individuals. And then, let's say, only these 6 individuals reproduce, right? And now, all of a sudden, there are only red individuals in this group, and the blue individuals, that trait is no longer present, right? A trait became extinct, if you want to think about it by that. And this is not because of any driving force of one trait being more favorable, right? This is completely random, right? Sorry about the news alert. This is completely random. And, you might say, well, this is not realistic. There are not many populations of just 20. And that's the point. Genetic drift is a lot more prevalent in smaller populations. The chances of something like that happening in a larger population is much, much smaller. Thus, why it's so important to have a very large and genetically diverse population, because, you can avoid something like that. Now, genetic drift is made up of two main components that you'll hear about, probably, and that is the bottleneck effect, right? The bottleneck effect and the founder effect, right? And I'm going to go ahead and I'm going to explain each one of these separately, right? So the bottleneck effect, I'm going to try my best to draw upside down bottle, right? This is how I like to think about it. Let's say at the top of the bottle, or the bottom of the bottle, if you're holding it regularly, right, had a large and diverse population, right? You had some blue individuals, you had some red individuals, right? Maybe you had some yellow individuals, right? You have a large and diverse population. And let's say right here, right, there was a sudden catastrophic event, right? Whether that's a meteor strike or a volcanic eruption or a famine that limited food, right? And then only a few of the individuals survived, right? And this event, it doesn't matter what trait you have, that does not separate you in your likelihood of surviving this event, right? So randomly, only a small fraction of this original population survives, and now you have a much smaller population, not representative, right, in terms of traits of the original population, right? And that population is much more at risk at genetic drift because it is so much smaller, right? That's the bottleneck effect, right? And then for the founder effect, the example I like to use is, let's say we had a pond right here, right? And this pond maybe is, separated by, a bunch of rocks, right? And after that, those rocks, there's a waterfall that leads to another pond, right? And let's just say in this original pond, right, there's a large diversity of fish, right? Let's say we have some red fish. Let's say we have some orange fish. Let's say we have some, yellow fish. Just a large, diverse population of fish, right? Let's say a flash flood occurred, right? Because of that flash flood, the water level rose, and some of these fish were able to escape, right? Only a small portion of these fish, right? Where before this pond, the lower pond past the waterfall, didn't have any inhabitants, now those red and orange fish, the few fish that made it, are founders of this new environment, right? Only some of the fish were able to make it. The water level dropped back down, so the rest of the population didn't. And now we have new founders of the population. Again, the certain trait that you have doesn't make it more likely that you escape this pond and go to the other pond, make it over the boulders. It's just by chance that some fish did and founded a new area. And again, their traits are not representative of the original population, and since their population is a lot smaller, they are more at risk at genetic drift, right? Another thing you might want to think about, let's say hypothetically that an ice bridge formed and connected the Americas with another population, and a small portion of that population crossed that ice bridge and came to the Americas and founded this land. It might not be representative of the whole population, and they founded a new area and created their own population, right? So that was a brief introduction of the idea of evolution, natural selection, genetic drift. Remember, natural selection has a driving force about what traits are more fit for the environment, while genetic drift is completely random.